Hey everyone, so today I'm going to talk about how to find the center of mass, but using examples, and this time I'm going to use numbers because I think some of you felt that variables make it a little bit confusing, right? So let's start with I have boom, boom. No, let's put this somewhere else. Boom. All right, and I think this is a jump from what we did last time, but I'll tell you how to do it. Say my coordinate of this particle is 2 comma 4, 2 comma 4, and that is the coordinate of this is maybe 5 comma 1, and the coordinate of this particle is say minus 4 comma 2. All right, and you have to find the center of mass of this system. Maybe say this has a mass 3 kgs, this has a mass 4 kgs, and this has a mass 2 kgs. Alright, now how do we go about this? So always when you have it in a coordinate system, when you want to find the center of mass for a coordinate system where you have both x and y, what do? You always separate out the coordinates. You take the x factors in another place and the y factors in another place. So you solve them separately. It's the same as how we work with vectors, right? You always work with the x component separately and the y component separately. So that's exactly what we're going to do. Let's first make a list of all the x components and the y components. Alright. So it's 2, 5 and minus 4. 2, 5 and minus 4. And the y is 4, 1 and 2. Right. And what were the masses of the particles? There were 3, 4 and 2, weren't they? So first we're gonna work with the x part. Alright. I take up too much space. But what am I doing? So we're going to work with the x parts first. Alright. How did I define the center of mass? Sigma mx mixi by sigma m. Right. What's m into x for this? What do you think m into x for this part is going to be? 2 into 3, that's 6. 5 into 4, 20, that's 6. Minus 4 into 2, minus 8. Alright. So center of mass for this is going to be, and sigma m is 3 plus 4 plus 2, that's what's 7 plus 2, 9. So when I multiply this, I'll put 3 to 2 plus 4 into, why is my handwriting so bad? 3 into 2 plus 4 into 5 plus 2 into minus 4 by 3 plus 4 plus 2. You don't have to write all the steps, you're not down. I don't know why am I doing this. So that's going to be, what's sigma mx? Is 18. So I'm going to get 18 by 9, and that's 2. And whoa, that's a perfect number. So my x, so that's going to be my x coordinate of center of mass. So when I write it, I'm going to denote it by xcom or xcm, however we write it. That's going to be 2, and let's set that aside. All right. So I'm going to take these 3 points, coordinates 2 comma 4, 5 comma 1, 4 comma minus 2, and let's say my mass of this particle is 3 kgs, this is 4 kgs, and this is 5 kgs. Now I want to find the center of mass of the system. How do I do it? Now the first thing you do is you separate out the x components and the y components. You have to work with them separately. So you find the center of mass in the x system and center of mass for the y system. So when you get the center of mass, it's going to be like some x comma y, isn't it? You're gonna have it's gonna have two coordinates, x and y. So you find the x coordinate of the center of mass and the y coordinate of the center of mass. It's the same way as we work with vectors, right? You separate out x and y and you work with them separately. So that's what we're gonna do. Let's start with, so that's what we're gonna do. Let's start with the x coordinates, right? So x, and let's take, this is my mass. I'm just going to make a small tabular representation. 2, 5, 4. Those are my x coordinates, and the masses are 3, 4, and 2. Okay. Now, how did I say we find the center of mass again? It's sigma mx by sigma m, right? Let's do that. What's m into x for the first one? It's going to be 3. It's going to be 3 into 2 plus 4 into 5 plus 2 into 4 divided by sigma m, that's 3 plus 4 plus 2. And you calculate, you get 6 plus 20 plus 8 by 3 plus 4, 7 plus 2, 9. 28 plus 6, that's 34. 34 by 9. Oh man, I don't like this number. Yeah, hopefully like when you write a paper or something, you get something nicer than this, but that's our x coordinate of the center of mass. So when I write it, I'm going to get xcom or xcm, it doesn't matter, they're both the same thing. 34 by 9. That's my x coordinate of the center of mass. Alright, now let's work with the y coordinate. So how do we work with the y coordinate? Is the same thing. The center of mass, the y coordinate of the center of mass is going to be sigma my by sigma m. So there I wrote x because those are the x coordinates. Here I'm going to write y because the y coordinates. It doesn't really matter. You know what to do and how to do it. So when I calculate this, I'm going to get 3 into 4 plus 4 into 1 plus 2 into minus 2 by 3 plus 4 plus 2. That's going to be 12 plus 4 minus 4 divided by 9. And that's going to get me 4 by 3, which is also not a nice number. Damn it. So my y coordinate of the center of mass is going to be 4 by 3. And if I want to represent this, if I say, what is my center of mass? Give me the coordinates. Wait, give me a second. That's going to be, oh, my center of mass. No, wait, now, my center of mass is given by 34 by 9, comma 4 by 3. That's a 9. So that's how I give my center of mass. So if I plot it, it's 34 by 9. That's close to maybe 34 somewhere here. It's going to be low. So if I put it on this thing, it's going to be somewhere here, I think. I don't know. Yeah, something like this, I guess. Yeah, no, it'll be here. You know what I mean. So that's how you get center of mass for a coordinate system if they ask you like that. Thank you.